Here we need to obtain the value of the constants a and b if the slope of the tangent to the curve at the point 1, 1 is equals to 2. So let us begin. So here we have the equation of the curve given by xy plus ax plus by equals to 2. So this is given in implicit form. So we'll have to perform an implicit differentiation. That means we'll take the derivative on both sides with respect to x. So let's say we have derivative with respect to x. We'll have to take the derivative term by term plus a times derivative with respect to x of x plus b times derivative with respect to x of y and derivative with respect to x of the constant 2. So for the first term, we have to apply the product rule here. So this will be x times derivative of y with respect to x plus y times derivative of x with respect to x plus a times the derivative of x with respect to x, so that's 1, plus b times derivative of y with respect to x equals to derivative of a constant is always 0. So we have x dy over dx in the first term and b dy over dx, which is the last term. So let's combine them. So we have x plus b times dy over dx. Plus we have y times dx over dx, so that's simply y. So we have y plus a equals to 0. Solving for dy over dx, so we will get dy over dx. That will be equals to negative times a plus y divided by b plus x. So this is our slope of the tangent. Now we are given that the slope of the tangent at the point 1, 1 is equals to 2. So that means dy over dx calculated at the point 1, 1. So this is equals to 2. All we have to do is substitute the value of x with 1 and y with 1 into our slope. So this will be negative a plus 1 divided by b plus 1. So this is equals to 2. Or simply negative a plus 1 equals to 2b plus 1. Let's rearrange the terms. So we will have negative a minus 1 equals to 2b plus 2. So we will take negative a to the right hand side. So we have a plus 2b. That will be equal to, we'll bring this 2 to the left hand side and rearranging the terms to get negative 3. So this is one equation, a plus 2b is equals to negative 3. So let's label this as equation number 1. Now our point 1, y is also going to lie on this curve xy plus ax plus by equals to 2. So that would mean that it should satisfy the given equation. So let's plug in the value of x with 1 and y with 1. So we have 1 times 1 plus a times 1 plus b times 1 equals to 2. So this means this gives us 1 plus a plus b equals to 2, or a plus b equals to 2 minus 1. So that will be positive 1. So we have another set of equations. Let's call it equation number 2. Now we can easily solve the equation 1 and equation 2 to obtain the values of a and b. So let's do that. So equation 1, we have a plus 2b equals to negative 3. And equation 2, we have a plus b equals to 1. So what we'll do, we'll subtract. So this will give us the a and a goes away, 2b minus b will be b, and negative 3 minus 1 will be negative 4. So we have obtained the value of b. Now let's use equation number 1. So from equation 1, we have a, so that will be equals to 1 minus b. So we have 1 minus negative of 4, so that becomes positive 4. So we have a value equals to 5. So these are the two values of a and b. A will be 5 and b will be negative 4. And for this particular case, the tangent to the curve at the point 1, 1 will be equals to 2.